These are water-stressed areas in the world in this century. Very high water stress, high water stress. The United States lights up very nicely. Okay, so we have a potential for desertification in the United States in this century if we continue business as usual. So these are some of the concerns we have. And it's true not only in the United States, but it's true in many parts of the world. There are other things that we're worried about. In the frozen tundra, there's a slow accumulation of carbon. Trees grow, moss grows very slowly, but something remarkable happens when they die. The microbes don't recycle because the microbes are asleep. And you've done this experiment many times in your own kitchen. If you take some food or vegetables or something, put it in the freezer, I'm not sure why you'd put a vegetable in the freezer, but never mind. Let's say a hunk of meat and put it in the freezer. It can be kept there for months. My wife doesn't want me to eat it if it's there for months, but it's actually edible for months. If you take it and put it in the refrigerator, it could be there, it could be good for 3, 4, 5 days. And the difference, a very subtle difference below freezing and above freezing is all the difference in the world. The microbes wake up when you're slightly above freezing. When you're slightly above freezing, that's what's happening in the tundra in Russia, in Alaska, in Canada. And these microbes are beginning to wake up. Now, there's a lot of carbon that's being stored there that's underground. How much, again, big uncertainties, but somewhere between half to maybe twice the total amount of carbon in the atmosphere today. If the tundra thaws, as it is doing, what happens, the microbes wake up, they release carbon dioxide and methane. Those greenhouse gases go in the atmosphere. That increased greenhouse gas layer then allows the globe to warm up even more, and the tundra melts some more. And so I was in Alaska 2 months ago, and I was being told in mid-Alaska that the pilings for building structures used to go down to 30 feet, but they're no longer good anymore because the tundra is melting. And so they have to go down to 40 feet. The ones that are 20 feet, the houses are collapsing. Okay, so this is happening big time already in the last couple of decades. Once this starts, then we're really scared because it's a runaway effect. Remember, the amount of carbon here is probably equal or more than the amount of carbon in the atmosphere in total. So then it's out of our control. So we have to, and that's why the climate scientists are saying we have to be even more aggressive. Now, this is a good news, bad news story. You just heard the bad news. But is there a reason for hope? And I say yes, there is a reason for hope. And so the message I want to communicate from here on in is not doom and gloom, but of optimism and opportunity. And let me give you one example of optimism and opportunity. This is the world grain production from 1960 to 2005. And in 1968, a book was published called The Population Bomb, written by a Stanford ecologist, Paul Ehrlich, and he said, despite the massive crash feeding programs that are being embarked on today, there will be hundreds of millions of people that will starve to death, that we simply cannot grow enough food for this rising population. And so what happened was Norman Borlaug was awarded a Nobel Peace Prize in 1970 for his work on developing hybrid strains of dwarf wheat that were more disease resistant, but most importantly could grow much more grain per unit acre, not only in the United States, but also in Mexico and India and Pakistan. Not a little bit more, not 20, 30% more by a factor 3, 4, or 5 times as much per acre in developing countries. And for that reason, the amount of land put under agricultural production for grain production remained constant, and the grain production went up like a rocket. And so he got a Nobel Prize. That was a game changer. There was another game changer at the beginning of the end of the 19th, beginning of the 20th century. In the early 20th century, there was an invention made by 2 chemists, Haber and Bosch, that they could use ammonia. They could synthesize ammonia from the air, from nitrogen, using a catalyst. And with that, with the ammonia you can make artificial fertilizer. And this was deemed so important that Haber it took him 10 years to develop this process. He got a Nobel Prize in chemistry for it, I think in 2018. And A decade later, Karl Bosch got a second Nobel Prize in chemistry for the same thing, because it enabled Europe to feed itself. It was that important. So those are examples where technology can come to play. There's a picture of Norman Borlaug when he was doing his cultivation of his grains, and later in life he just recently died, this last month, but truly a remarkable contribution. So what I see in my crystal ball is I see a world where price of oil will go up because of supply and demand, because we're already transitioning to much deeper offshore oil, and the developing countries are demanding much more of it. We will live in a carbon-constrained world. Whether we live in a carbon-constrained world a year or two from today or a decade from today, as countries wake up to this, we will have that happen. So, given these two constraints, highly likely for this to happen, we have a choice. We can either wish that oil prices may go down. There's a chance they might go down to $20, $30 a barrel. There's a chance that maybe all this climate stuff is a hoax. Or you can recognize where the world is going. And so I'm reminded of a quote by the great hockey player Wayne Gretzky. When asked why was he such an effective hockey player, he said, "I skate to where the puck is going to be, not where it's been." So I'm asking the United States to skate to where the puck is going to be, not where it's been. And if we do that and rev up the American innovation engine, a lot of wonderful things can happen. What has happened in the past? Well, we invented assembly line technology for automobiles. We invented the first airplane. We invented the first electrical generation distribution system in the world, Edison, and then competition between Edison and Westinghouse. More recently, we invented photovoltaic cells. We invented the first transistor, the integrated circuit, that led to a computer internet revolution. We invented the laser. We invented the internet. And even Rochester shows up. There were 37,000 hits. But where are we today? Well, in high technology manufacturing, these are pharmaceuticals, test equipment, electronics, aerospace, things of that nature. The United States is here losing market share from 1989 to today. China has grown and taken over from the United States, from the European Union, from Japan. So China is marching. China is not dominating in low-cost manufacturing. They're dominating in high-end manufacturing as well. And there's no reason why the United States should concede high-technology manufacturing to anyone in the world. We invented the solar cells, invented the Bell Laboratories. This is our U.S. market share of photovoltaics around the world as China grows. This other is mostly China and Japan and Europe. It's not only true of photovoltaics, it's true of fuel-efficient automobiles. If you buy a hybrid vehicle today, 99% of those batteries are made in Asia. Electricity transmission, something we invented. We're behind. We lost the lead to Europe maybe 15, 20 years ago, but now Asia is trying to take that over. Nuclear power, which we developed, the first nuclear reactor was built in the United States. It's now dominated by France and Japan. I visited China once about 2.5 years ago. I was a co-chair of a study that represented over 100 academies around the world. How do we transition to a sustainable energy future? So I had the privilege of talking with the Premier of China, Wen Jiabao, for about an hour. And he told me what things China was doing in terms of increased energy efficiency, closing down old, inefficient coal plants, things of that nature.